Hello again. This is Kim Wilcox, and today we're going to cover dosage problems based on weight. When it comes to weight in nursing, you will need it for two separate things. For this one, you're going to find out your patient's dosage based on his weight. Later, you will learn how to determine if what the doctor ordered is safe based on the recommended daily dosage for that patient. So right now we're just going to do dosage problems based on weight. And this is where there's a lot of different medications that are dispensed based on patient's weight, like 25 milligrams per kilogram. So you'll have to multiply the dose by his weight. And this allows the medication to be specific to that particular patient. It's very important when it comes to peds as well. So here's a few very important things to keep in mind. Every time you're rounding weight, you're going to round it to the tenths place. You also have to pay very careful attention if it's per day or per dose. Sometimes it can be given per day, and you need to find out how much it is per dose. Or they give it to you per dose, and you'll need to find out how much it is per day. The other thing that is very, very important is you have to find out, when you're going between day and dose and day, a few things you always need to pay attention to. So whenever you want to do the math to find out how many doses they're taking, which is where you would do the math, you have to break it down. So if it says every 4 hours, so if you're giving your patient medicine every 4 hours, that's 6 doses or 6 times a day. So this is what you would end up doing the math with, not every 4 hours. You care about how many doses or how many times a day. If it says every 3 hours, it's the exact same thing. You don't want to do the math inside your problem with the 3. You want to know how many doses or how many times a day. So you would use the 8 times a day, because if you're giving it to him every 3 hours, that's 8 times a day. You also need to make sure you know your abbreviations, because BID is twice a day. So you're just going to use that number because it's 2 times a day. Sometimes they'll tell you 4 times a day. And again, if it's 4 times a day, you do the math with that number. Okay, so some meds are dispensed by body weight. And of course, the heavier the body is, the more the medicine that is needed. So for this one, it just says, okay, how much medication would you deliver to a 5 kilogram patient if the order is for 0.1 milligram per kilogram? Now, when it says 0.1 milligram per kilogram, honestly, the easiest thing to do is right here, just multiply by his kilograms. So when you multiply 0.1 times 5, you would end up with 5 milligrams. For dimensional analysis, which you are also able to use, to just explain how those kilograms then go away and you're only left with milligrams, it would be 0.1 milligram per 1 kilogram, but your patient is 5 kilograms over 1. And you're going to cancel those kilograms, and again, you're going to see all you're going to do is multiply, so you'll get 5, and the only unit that's left is a milligram. So if you can always solve it like this, that's perfectly fine. But I usually just multiply by his kilograms down here. But always remember that when you multiply like this, that kilogram goes away because they're technically being canceled out. And then your answer would be left in the measurement of the medication, which here is 5 milligrams. Okay, so for this one, you're going to be calculating dosages based on weight. And so what the order is for 20 micrograms per kilogram by mouth every day. What you have on hand is a liquid labeled 250 micrograms per 1 milliliter, and the child's weight is 44 pounds. So the first step with all of these basically is you're going to multiply, you're going to convert the weight. Pay very careful attention. Sometimes they'll give it to you in kilograms, sometimes they don't. For the second step, you're going to multiply his dose times that weight. Okay? And then after that, you're going to probably usually have to set up the regular dosage problem, which is what we've been doing so far, what's ordered over what's on hand times the quantity. So for this one, the first thing we're going to do is we're going to change his weight. So we're going to take the 44 pounds to kilograms. So we do 44 divided by 2.2, and that gives me 20 kilograms. Okay, for step 2, right here, we're going to multiply the dose times his weight. And so I know he's 20 kilograms. So anytime you see this per kilogram, that means for 1 kilogram. Well, our patient is 20. So you're going to multiply by his kilograms. And you're going to get 20 times 20 should be 400. And the unit is microgram per kilogram. Now again, those canceled, the 2 kilograms canceled. Once you do this, it might be very helpful to mark this out because you've already done that math and you do not need this information again because you have now found his new dose. And his new dose is 40 micrograms every day. Okay, and then the last step is your dosage problem. So the dosage problems I'll do in green. So the dosage problem is what's ordered, which is the 400 micrograms, because that is what is ordered for your patient. 400 micrograms. What you have on hand. Hold on one second. Okay, so what was ordered is the 400 micrograms. What you have available is the 250 micrograms per milliliter. So we cancel those units. So you do 400 divided by 250 times 1, and you get 1.6 milliliters. Okay, so this is your answer because the question would ask you how many milliliters will you give. Okay? And these are the steps written out for you. So again, just to go through them, it says that the order is for 20 micrograms per kilogram. The weight is 44 pounds, and you have what's available is 250 micrograms per 1 milliliter. So the first thing we did was we converted his weight into kilograms, right? Always round to the tenths place, but it did come out nicely to 20. The second step, we found the doctor's actual dose based on how the medication times his weight, which was the 20 micrograms times the 20 kilograms, and again, those cancel, so you get 500 micrograms for your patient, okay? So this is, again, his new dose. Then you're going to do, we were using, I think, the green for the dosage problem, so what's ordered over what's on hand times the quantity. And you can find this slide on CAMS. Okay, so the physician orders Sustiva 20 milligrams per kilogram by mouth, Q12H. Okay, you have Sustiva 50 milligram tablets. His weight's 11 pounds. How many tablets are you going to administer? So this time his weight is in pounds, so the first thing you're going to do is change his pounds. So you take the 11 divided by 2.2, because all of these are going to be based on his kilograms. So you would get 5 kilograms. So this is his weight. Okay. Then you need to go back to what is ordered for him. So every patient is getting 20 milligrams per kilogram, and I'll write it over here. So 20 milligrams, and you're going to multiply it by his weight, which was 5. So he is getting 100 milligrams. And this is his new dosage. Okay? So once you've done multiplying by the kilogram, you do not need that anymore, because his new dose is 100 milligrams. Now, you do a dosage problem. So what's ordered? Well, his new dose is 100 milligrams. What you have on hand is right here. You have 50 milligrams per tablet. Okay? Cancel your units so you know they're in the right place. So 100 divided by 50 is 2 tablets. Okay. So for these, you want to also make sure that you read all the questions carefully. So a physician ordered chemotherapy for your 143-pound patient. Determine the dose the patient should receive per day for the following order. So he's getting 16 milligrams per kilogram per day, and he should receive blank grams. Okay, so you don't have to go through every step. Now for this one, you will have to, right here, I was using the blue here, you still have to deal with his weight in kilograms. So the first thing you want to do is change his 143 to kilograms, and you get 65 kilograms. Okay? The second step is you're going to take this part right here to find out what his dose is. So his dose is going to be 16 milligrams per kilogram per day. So I'm going to multiply the 16 times his weight, and I get 1040 milligrams per day. If it says per day at the end, you should write per day. If it says per dose, you should always write per dose. Now, this is one that came up, not in this much detail, but earlier, and a lot of people missed it. The issue is he's going to get 1,040 milligrams per day. But look at what the question says. He should receive blank grams. So you can't tell me 1040, because the 1040 is in milligrams. That is a wrong answer for this problem. So they want you to go to grams. So to convert milligrams to grams, you would divide by the 1,000, which would then give you 1.04 grams. And it does say round to the 100th, so we already have that answer. So this is your final answer. The biggest thing is, again, what most people do is give me the milligrams. But the question specifically asks for grams. Also, people forget the part where it says to round to the 100th, because a lot of times people don't go back and read that over again. Okay. So, now you have Solumedrol 2.5 milligrams per kilogram for a child weighing 20 pounds. Solumedrol is available in 125 milligrams per 2 mLs. How many milliliters will you give? So, first step, we have to change his weight. So to go from 20 pounds to kilograms, we do 20 divided by 2.2. And I have 9.1. Let's see what it was actually on the calculator, though. So let's see. 20 divided by 2.2. And I get 9.09. All weight is to be rounded to the tenths place. If you leave it as 9.09, or if you round it to just 9, the entire problem will be wrong. So you have to round to the tenths place. So that 9 makes that 0 go up to a 1. So his weight is 9.1 kilograms. Step 2. You're going to take what's required for him. Every patient's getting 2.5 milligrams per kilogram. So you're going to take the 2.5, and you're going to multiply that times his weight. 9.1 in kilograms. I usually don't write it. We just do the math. And you get, where's my problem? 2.75. to 0.75 milligrams. Now, this, you don't round. You don't round this because we know certain rounding rules, right? We know to round if it has to do with weight. You round to the tenths place. Syringes, you have to round accordingly. But this is a dosage. This is how much medicine he's getting. You never round this unless you are told to. So now you're going to go ahead and you're going to do your dosage problem based on his new dose. Because once you did this, it's all gone. So his new dose is 22.75 milligrams. Okay. What you have on hand is 125 milligrams per 2 mLs. You cancel. So when you do the math, you get, here it is, you get 0.364. Okay? And sometimes it'll say round based on the syringe, or sometimes it won't. The 1 milliliter syringe is specifically called the tuberculin syringe. Tuberculin syringe. Okay? And a tuberculin syringe is only the 1 milliliter syringe. So if you, and it sometimes it might say based on the syringe. Well, you're giving less than 1 milliliter. So, of course, if you're giving less than 1, you're only going to use that 1 milliliter syringe, which is the tuberculin syringe. And the rules for rounding milliliters, I'm running out of room, but up here, if it's less than 1 milliliter, if you remember correctly, we round to the hundredths. And if it's greater than 1 milliliter, you round to the tenths. Okay, and these are ones you have to memorize. So since it is less than 1, and you would use that 1 milliliter tuberculin syringe, you'd round to the hundredths, and you would get 0.36 milliliters as your final answer. Okay, just a couple left. Okay, so you're going to calculate the amount to administer, and you have a 10-year-old patient who weighs 60 pounds, and he's getting, whatever that is, 30 micrograms per kilogram now, and you have available, and they give you a label. So, you see where it says per kilogram, so the first thing I'm going to do is I'm going to change his pounds to kilograms. Don't forget to round to the tenths place. So you get 27.3 kilograms. Okay? Now you want to find his dose specifically for him because he's 27.3 kilograms. So you're going to go right here and you're going to multiply by his kilograms. So you take 30 milligrams times his kilograms and you get 819 milligrams. Okay? So this is his new dose. So you don't need this anymore because you've already done the math. And you're done with the weight. So now we just go straight to the dosage problem. So for your dosage problem, he's now ordered 819 milligrams over, and this is the information you use for, hold on, let me make sure you can see what unit this is clearly. This is a microgram. And just to make sure I wrote it actually clearly up here, this is a microgram. Okay. So he's getting 819 micrograms. And what you have available, where'd my available go? Right here. 5 milligrams per 1 ml. But then you notice the problem. One says microgram, one says milligram. You can change either. I'm going to go ahead and change my milligrams to go to a microgram by multiplying by 1,000. So then my problem would be 819 micrograms over, what's that, 5 1,000 micrograms times 1 milliliter. And since they match, they can cancel. Now again, you're going to get an answer. My answer says 0.1638, on and on and on. And these are milliliters. Since this is 1 milliliter, it's going to go in the 1 milliliter tuberculin syringe. So you're going to round to the hundredths place. So that 3 makes that 6 stay the same. So you get 0.16 milliliters as your final answer. Okay? This is one more I put in there. Just wanted to go over a question where sometimes they ask you milliliters or sometimes they ask you milligrams. So, for this problem, your patient is getting 25 milligrams per kilogram per dose, BID. The medication's available in 50 milligrams per 5 mLs. Oh, look, I didn't even give you the patient's weight. How many milliliters will you receive? Okay, let me throw in his weight, because again, I just made this up. So let's say, hold on one second for me. Okay, for this one, I've just decided to get rid of the kilograms because it doesn't affect the concept I'm trying to teach you. So we'll say the dose that what the doctor prescribed is just going to say 25 milligrams per dose, BID, because this is what we need to know. So, right here, the first question is, how many milliliters will you administer? Now, what the doctor is giving him is 25 milligrams per dose, BID. So, he's only going to get 25 milligrams right now. Okay? So, all you're going to do for this one is do your regular dosage problem. So, he's going to get, I think I was using green for that. So it was 25 milligrams is what's ordered over 50 milligrams per 5 mLs. So, let's see, that should be half of 5, but just to double check my math. 25 divided by 50 times 5, yeah. So you get 2.5 milliliters. And that's the first part. Now, the second part is, you got to be very, very careful here where it says how many milligrams will the patient receive per day. Okay? This has nothing to do with your milliliters. This is specifically talking about the milligrams in his medication based on what the doctor is giving him. Well, the doctor is giving him 25 milligrams every dose, and BID means 2 times a day. So think about that. If he's getting 25 milligrams per dose and he's getting that twice a day, how many milligrams is that per day? So you just do 25 milligrams times twice a day, and you would get 50 milligrams per day. And I can't express enough the importance of writing every single unit every single time, because that will help you keep up with all of this as detailed as it gets. Because we're getting ready to do safe dose ranges, which has a lot of per day and a lot of per dose, and you can get lost in the problem if you do not write all your units. Okay, so this is dosages based on weight, and so I'll get ready to send this out. Y'all have a nice evening.